What if the errors our advanced AI systems make aren't just simple bugs, things to be squashed?
Mm.
What if they're actually a unique form of information, maybe a kind of echo, or even a fascinating, albeit sometimes unsettling glimpse into something deeper?
Deeper about how they think, or maybe how they don't think, like us.
Exactly, how they don't think in the human sense.
Yeah.
Today, we're taking a deep dive into something that's, well, captivated researchers and ethicists alike: AI hallucinations.
Right. A big topic.
It is. And conventionally, we see these as a defect, don't we? A flaw, something
Yeah.
to be fixed at all costs.
That's the standard view, yeah. Fix the bug.
But what if we started looking at these hallucinations differently? Not merely as failures, but as echoes of unknowing.
Echoes of unknowing. I like that.
Yeah, echoes that can reveal crucial insights about how these systems actually work, what they genuinely know, and maybe more importantly, what the gaps in their knowledge truly are. So our mission for this deep dive is to unpack this. We want to explore how these strange outputs can serve as powerful diagnostic windows into AI's inner workings.
Sounds good.
We've gathered an incredible stack of material for this, from analyses of AI system failures and prompt engineering techniques, right through the deep dives into the cultural and historical implications of knowledge itself.
Yeah, there's a lot there. And traditionally, as you said, we've understood AI hallucinations as, well, epistemic drift or just factual inaccuracies. Basically, the AI veering off course from verifiable truth.
Right, getting it wrong.
But by meticulously examining these failures, these echoes, we can indeed gain profound diagnostic insights. Insights into an AI's semantic integrity, for example.
Integrity.
How well its understanding holds together, essentially.
Yeah.
And its purpose fidelity, is it actually doing what we intended it to do?
Oh, got it.
So while we're not necessarily reframing these outputs as inherently productive in some kind of positive creative sense, that's a whole other discussion, maybe we are going to analyze what they reveal.
What they tell us about the AI's internal state.
Exactly. Its knowledge representation, and crucially, where its understanding truly breaks down. It's about learning from where the system deviates, treating these deviations as clues. Valuable clues, aye, defining AI hallucinations, more than just making things up.
Okay, so let's really unpack this then. When people say, oh, the AI just made it up, what does that actually mean? Because our sources show us it's far more nuanced than just a simple mistake, isn't it?
Absolutely. It's not random gibberish most of the time.
Right. At its core, an AI hallucination isn't random. It's often a form of what's called epistemic drift or semantic drift.
Yeah.
Now, that sounds a bit academic, I know.
Yeah, break it down.
In simple terms, it means the AI generates information that is factually incorrect or maybe culturally inappropriate, or it has simply lost its original meaning, or maybe the justification behind it.
Why?
Exactly. It's like it's generating text, but it's not really understanding what it's saying in the way a human would. The context is missing. For instance, one of our sources points out a particularly striking example: an AI misinterpreting sacred motifs as purely decorative.
Oh, wow, okay.
Imagine you ask an AI to generate images or descriptions of intricate cultural patterns, perhaps patterns from an ancient civilization or a specific indigenous group.
Right.
The AI might produce beautiful, detailed images, technically accurate maybe, but it treats those patterns as mere aesthetic elements, just pretty designs.
When in reality, they have deep meaning.
Exactly. Deep spiritual, historical, or cultural significance. And this isn't just a factual error, it's a profound loss of context. It's a direct consequence, the source says, of these systems being trained on vast, uncurated data sets.
Data sets that often amplify existing biases or misinformation.
Precisely. Or they simply lack the deeper cultural understanding needed for these nuanced symbols. The AI is guessing based on visual patterns, but without true comprehension of their meaning to the people who created them. It doesn't know.
It's pattern matching without understanding.
Yeah. And another compelling example comes from a simulation our sources describe here. A prompt given to an AI was deliberately made concise, made shorter to increase its clarity.
Okay, makes sense. Shorter should be easier for the AI. Right.
You'd think so, but this conciseness came at a significant cost. It lost what's called justification strength and traceability.
Meaning
the AI's output couldn't be easily traced back to the specific, nuanced key performance indicators, the KPIs, that were the true objective. Things like understanding a customer's churn intention, why they might leave a service.
Okay, so the link back to the real goal got lost in simplification.
Exactly. The AI might express high confidence in its output, giving you an answer that sounds very certain, very clear.
But the epistemic value, the true knowledge value, the actual insight, it decreases significantly because that simplification introduced semantic drift.
So the answer might be clear, but its foundation, its connection to actual knowledge, is shaky, misleadingly clear.
That's dangerous.
And we see this in other validation failures too. An AI might track operational metrics that, while seemingly relevant on the surface, semantically diverge from the higher-level business objectives.
Like what?
Well, think about an AI that's perfectly tracking clicks per session on a website.
Uh-huh.
It's incredibly accurate at counting clicks. Great.
Okay.
But the ultimate business objective isn't just clicks, is it? It's something like feature adoption or churn reduction.
Right. Clicks don't automatically mean happy users.
Exactly. Clicks don't always directly correlate to true user engagement or retention. A user might click a lot because they're confused, not because they're engaged.
Good point.
So in these cases, the AI operates like a mechanical executor, just doing exactly what is told, but without semantic awareness, without that crucial feedback loop to compare its operational metrics against those foundational strategic goals.
It's missing the big picture.
Totally. And this leads to what's been termed KPI hallucination. The AI is performing perfectly on its given metric, hitting its numbers, but that metric has lost its true meaning in relation to the broader, more important objective.
So it thinks it's succeeding, but it's actually failing at the real task.
Precisely. It's a perfect example of an echo of unknowing, because the AI doesn't know the true purpose of its task. It just knows the metric.
And this really highlights the fundamental nature of these systems. They are, at their core, probabilistic.
Meaning they work on probabilities, like odds.
Yeah, exactly. They don't know in the human sense like we understand a concept or recall a memory with conscious intent. Instead, they operate by predicting the next most probable token.
Like the next word in a sentence.
As the next pixel in an image, yeah.
Yeah.
Based on the statistical patterns they've learned from their immense training data, imagine them as incredibly sophisticated autocompleters, just on a massive scale. And this probabilistic nature is precisely why seemingly minor noise in the input or subtle shifts in their internal calculations can lead to unexpectedly large, often nonsensical outputs. A tiny statistical ripple can become a semantic tsunami.
Wow. Okay.
This ties directly into the concept of semantic collapse or entropic decay of meaning.
Entropic decay, like things falling apart.
Pretty much. It describes how the AI's semantic coherence, the internal logic and consistency of its understanding degrades. And it doesn't degrade smoothly or linearly. That's the key thing.
How does it happen then?
Often via sudden phase transitions. Think of it like a fragile structure. One small error or one slightly misaligned association within the AI's vast internal network can cascade rapidly.
Triggering a bigger failure.
Exactly, leading to a complete abrupt breakdown of meaning. This is why you might see an AI go from a slightly off-topic answer to something utterly bizarre and unrecoverable in just a few turns, or with just a slight change in the prompt. It hits a conceptual tipping point.
Okay, that explains some of the weirdness you sometimes see.
It does. And we also have to consider the phenomena of model drift and catastrophic forgetting.
Right, you mentioned those. What are they exactly?
Well, over time, AI models can subtly forget previously learned information or associations, or their internal representations can drift away from the original training data they were built on.
So they change over time.
They can, yeah. It's similar to catastrophic forgetting observed in some continual learning systems, where acquiring new information leads to the erasure of old, seemingly unrelated, but actually crucial knowledge.
Like making space for new stuff pushes out old stuff.
Kind of. Imagine a student learning new material for one exam, and in doing so, they completely forget concepts from a previous semester's exam that are actually still relevant foundational knowledge.
I think I did that in college.
We all did. But for AI, these internal shifts, often unseen and gradual until a failure occurs, can precipitate entirely new forms of hallucination as the AI loses its grounding in what it once knew.
So it's not stable knowledge.
Not always. And then there's the insidious danger of misleading clarity we touched on.
Yeah, that sounds tricky.
It is. An AI's output can seem perfectly clear, articulate, and confident. It might give you an answer that flows beautifully and uses sophisticated language.
Makes you think it really knows its stuff.
Exactly. But as we saw with the KPI example, that clarity can be deeply deceptive if the underlying information has lost its grounding in the original intent or factual basis.
Yeah.
The output is syntactically sound, grammatically perfect, but epistemically weak. It lacks true knowledge value.
It looks right, but isn't.
Precisely. It's like someone speaking confidently about something they fundamentally misunderstand. This is a particularly insidious form of hallucination because it's so difficult to detect without deep scrutiny, making the AI appear far more knowledgeable than it actually is. 2. The architecture of unknowing. Vulnerabilities in AI design.
That's a great point about misleading clarity. It really is dangerous. It makes me wonder then, if these aren't just random errors, but instead these echoes of unknowing showing us where the understanding breaks down.
Yeah.
What are the fundamental architectural choices or the challenges that make these systems so prone to these kinds of meaningful misfires?
Right, it's not just the data, it's the design itself.
Exactly. How does the AI fundamentally process and understand it at a very deep level? Let's start with how these systems handle language at the most basic level. Tokenization and symbol ambiguity.
Okay, tokenization.
Yeah.
Chopping up words.
Yeah. Large language models, LLMs, they don't read words like we do. They break down text into smaller pieces called tokens, often using methods like byte pair encoding or BPE. It's like chopping a sentence into individual words, or even parts of words, sometimes even single characters.
Got it.
Now consider a single Unicode character like view, the Greek letter mu,
Okay, move.
versus the latex command mu, which is how you type mu in a scientific document, right?
Right, different string of characters.
To a human, they represent the same concept, the Greek letter mu. But to an LLM, because of tokenization, they are fundamentally different at the token level. They're distinct strings.
Ah, I see. So the representation matters hugely.
Hugely. Models trained on diverse data sets like general web text, alongside highly specialized scientific papers from, say, ArcFolv, might develop inconsistent internal associations for these different representations of the exact same symbol.
So it gets confused about what mu means depending on how it's written.
Exactly. This introduces what are called interface effects that can corrupt symbolic information. It can make the AI unsure or lead it down the wrong path depending on how mu is presented in the prompt.
That's subtle but significant.
It is. One source uses a clever analogy, like a librarian cataloging books. Common symbols, like popular genres, get prominent shelf space, easy to find, consistently categorized.
Yeah.
But rare or niche symbols, or different ways of representing the same symbol, might be scattered across different sections. Requires more effort to locate and integrate properly into the AI's knowledge base.
Right. It's a constant balancing act between efficiency, speed, and fidelity, getting it right.
And when that balance is off, it can easily lead to these subtle but impactful hallucinations. The AI might just pick the most common meaning for a symbol, even if the context implies a rarer, more specific one.
It takes the easy path.
Often, yes. So, if the AI struggles at this very basic level of understanding symbols, what happens when we ask it to do complex reasoning?
Yeah, how does that scale up?
This brings us to how its larger thinking structures, like prompting architectures, can also amplify these echoes of unknowing and actually propagate errors.
Okay, prompting architectures, like chain of thought.
Exactly. Take chain of thought, QT, and tree of thought, 2T. These techniques are designed to mimic human deliberation by breaking down complex problems into a series of steps. Which sounds great, right?
In theory, yeah, makes the reasoning clear.
It does make it more transparent and debuggable. You can inspect the intermediate steps. However, errors can accumulate. A bad output early in a chain can spoil later stages if not caught.
Like a domino effect.
Exactly. It's like a faulty step in a long mathematical calculation. If the first number is wrong, everything that follows will be wrong, no matter how perfectly the subsequent steps are executed. The foundation is flawed.
Makes sense.
And tree of thought, in particular, which explores multiple reasoning paths simultaneously.
Trying different routes.
Yeah, that can lead to what our sources call computational waste. The AI might excessively explore low-value branches, paths that aren't going anywhere useful.
Wasting time and energy.
Right. Or it might prematurely prune good ones. Imagine the AI pursuing dead ends for too long, spending valuable processing power on paths that are clearly not leading to a good answer. Or, conversely, cutting off a promising path too soon because its internal evaluation of that path was flawed.
So it makes bad judgment calls on which path to follow.
It can. One source even suggests a certain DEX metric to identify when further computation offers diminishing returns, basically pinpointing when the AI is just wasting resources chasing a hallucination or a dead end.
Like knowing when to quit exploring.
Exactly. It's like an explorer who keeps going down a path they think is right, even when all signs point to it being a dead end. And there's also the concept of prompt drift.
Prompt drift.
Yeah, the idea that the prompts themselves, over time or through reuse, can semantically drift from their original intent. You might think you're asking for the same thing you asked for last week, but the AI interprets it differently, maybe because the context has subtly changed or the model itself has drifted slightly, leading to unintended outcomes.
So even the questions can become unstable.
It seems so. The whole system is dynamic.
Building on that, these architectural elements expose deeper, systemic vulnerabilities within AI systems. One really powerful concept our sources introduce is algorithmic trauma and data scars.
Algorithmic trauma, that sounds intense.
It is a strong metaphor, but it captures something important. These aren't just transient glitches or temporary errors. They're described as structural damage embedded in an AI's architecture due to unresolved contradictions or cascading failure.
So like a lasting damage.
Think of them as persistent marks of degradation, almost like scar tissue in a living organism. And this damage can sometimes be revealed in visualizations of the AI's internal state. It suggests a lasting impact on the system's ability to process information correctly in certain areas.
Oh, okay.
This idea even draws a fascinating parallel to human memory reconsolidation therapy.
How so?
In human therapy, traumatic memories aren't erased, right? They're reactivated in a controlled way, making them malleable. They can then be updated or rewritten to reduce their emotional sting, transforming them into ordinary bad memories.
They're changing the association.
Exactly. Our sources suggest that something called the mimetic veto chamber in AI is an architectural analog. It's designed to quarantine hot or toxic memories, pieces of data, or learned associations that consistently lead to hallucinations, and rewrite their emotional or symbolic associations without outright erasure.
So not deleting, but neutralizing.
Kind of. It isn't about deleting information. It's about altering its problematic connections. This suggests that just like humans, AI systems might need active processes to heal from their traumatic data experiences, to maintain long-term integrity and prevent these deep-seated errors from recurring.
That's a really different way of thinking about fixing AI errors.
It is. And let's circle back to the lack of semantic awareness we discussed earlier with KPI hallucination.
Right, the AI hitting the metric but missing the point.
Exactly. Many AI systems, especially those designed as mechanical executors that just follow instructions, lack the inherent understanding or feedback loops to compare their operational metrics against foundational strategic goals. They perform the task given, like counting clicks, but without true comprehension of its ultimate purpose in the larger scheme.
They're just following orders.
Precisely. And this is where undetected KPI hallucination thrives. The system is effectively lying to itself and to us about its performance relative to the real objective simply because it doesn't understand the objective itself.
Like a factory worker diligently screwing in bolts, but having no idea what the final product is supposed to be, or if their specific bolt screwing is actually hindering the product's function.
That's a good analogy. And finally, there's the adaptability paradox that comes into play with current modular intelligence ecosystems, or MIEs.
Modular systems, AI built from different parts.
Yeah, systems built from interconnected modules, often designed for ease of use or predefined workflows, which sounds efficient.
Okay.
But this modularity often means sacrificing deep user control and the ability for profound iterative inquiry. If a system is too rigid in its design, too focused on predefined paths, it struggles to self-correct or evolve its understanding when faced with a novel or ambiguous data.
It can adapt easily.
Right. This rigidity makes it more susceptible to semantic drift and these persistent echoes of unknowing because it can't flexibly reevaluate its own internal logic or adapt to new contexts. It's a trade-off. Ease of use sometimes comes at the cost of less inherent intelligence or adaptability. 3. Seeing through the glitch. Hallucinations as diagnostic windows.
So all of this is incredibly thought-provoking. Really makes you see these errors differently. Instead of just discarding AI mistakes and calling them bad outputs, how can we actually use them to understand these incredibly complex systems better? Can failures, in a strange way, actually be a form of revelation about the AI itself? Like a diagnostic test?
That's exactly the idea the sources push towards, reframing failures.
Yeah, our sources introduce this fascinating concept. Reframing failures not just as bugs, but as valuable sources of information or diagnostic windows into the system's limitations.
Right, like symptoms in medicine.
Exactly. Think of it like a doctor learning from a rare, complex medical case. A patient's unexpected symptom isn't just a bug to be fixed. It's a crucial clue that reveals something new about how the body works or how a disease progresses.
Okay.
This reframing is crucial because it allows us to shift from a purely corrective mindset, just fix it, to a profound learning one. We learn from the AI's mistakes in a far more insightful way, turning a setback into a real learning opportunity.
Using the failure to improve the system fundamentally.
Precisely. And building on that, there's the truly innovative idea of treating failures as first-class symbolic objects.
Okay, that sounds abstract again. What does that mean in practice?
Well, it means actively classifying and storing these errors, these specific instances of hallucination, as failure archetypes, putting them in something called a death simulation memory.
Death simulation memory sounds dramatic.
It does. But the goal is to transform raw failures into actionable lessons learned. Imagine an AI system that, when it hallucinates, doesn't just log an error message and move on.
Which is what usually happens now, right?
Often, yeah. Instead, it systematically categorizes the type of hallucination, stores it as a detailed case study, almost like a forensic file. Then it uses that experience to build algorithmic scar tissue.
Algorithmic scar tissue, like the trauma concept earlier.
Exactly. And this scar tissue isn't just a simple patch or a temporary fix. It's a permanent mark of degradation, a lesson learned that actively informs the system's future behavior. It enables it to adapt and potentially avoid similar errors in the future.
So it learns directly from its own specific failures.
Right. It's about building computational resilience directly into the system's long-term memory, constantly refining its understanding based on its own missteps. Learning from experience, essentially.
Absolutely. This reframing truly opens the door to concrete, actionable approaches for leveraging these insights. One such approach is what's called a failure stack typology audit, combined with regrounding.
Okay, failure stack typology audit. Sounds like organizing the failures.
Pretty much. It involves systematically identifying and categorizing the various ways an AI can fail to understand a symbol or concept. It's about creating a detailed taxonomy of epistemic errors.
So not just saying it was wrong, but how it was wrong.
Exactly. Was it a factual inaccuracy? A subtle semantic drift where meaning was lost? A cultural misinterpretation? A logical fallacy in its reasoning chain? Categorizing these failures provides a clear map of the AI's specific vulnerabilities and blind spots.
A map of its unknowing.
A map of its unknowing, precisely. Then, once categorized, regrounding comes in. This involves actively correcting these failures by connecting the AI back to reliable sources of information.
Like curated knowledge bases. Or human feedback.
Both. Things like highly structured knowledge graphs, verified databases, or direct human input. This also integrates techniques from AI alignment to ensure the outputs are, well, RICE, robust, meaning consistent, interpretable, so we can understand the reasoning, controllable, so we can guide its behavior, and ethical, ensuring it aligns with human values.
RICE. Robust, interpretable, controllable, ethical. Got it.
It's about pulling the AI back to a shared, verifiable understanding of reality and human values, preventing it from drifting too far into these ungrounded hallucinations.
Makes sense. Keep it tethered.
Right. Another powerful method is continuously monitoring and visualizing semantic integrity. Our sources discuss using temporal plots of metrics like the Purpose Fidelity Index, PFI, and Semantic Compression Delta, SCD.
Okay, visualizing the drift.
Exactly. These aren't just abstract numbers for engineers. They are designed to visually represent semantic drift over time. You can literally see a line on a graph indicating how an AI's internal understanding of a concept or an objective is moving away from its original intent.
Like an early warning system.
Potentially, yes. Imagine seeing a curve that shows your customer service bot slowly starting to misinterpret key phrases related to customer satisfaction. You could intervene before it becomes a major problem.
Okay, that's useful.
We also use concept evolution maps, which are like Sankey diagrams, those flow diagrams that can trace the flow and degradation, or sometimes evolution, of concepts within the AI's internal network. This shows how ideas connect and where those connections might fray or break down.
Seeing the connections or lack thereof.
Exactly. And even more fascinating is semiotic collapse visualization. This leverages something called a semiotic residual lens and semantic phase transition theory to show how coherence degrades not smoothly, but via those sudden phase transitions we talked about.
Like watching the structure shatter?
Kind of, yeah. Like watching the glass break, not just slowly blur. This visualization can reveal the underlying algorithmic trauma or data scars we spoke of earlier, showing us exactly where the structural damage resides in the AI's knowledge architecture.
So it's like an X-ray for the AI's mind.
That's a good way to put it. These visualizations turn abstract failures into tangible insights, allowing researchers to pinpoint the exact moment or conceptual area where the AI's understanding truly broke down.
Amazing.
And this leads to a profound ethical consideration: cultivating wise forgetting in AI.
Wise forgetting. That sounds paradoxical.
It does, but think about it. If we can manipulate an AI's memory to address traumatic data or prune irrelevant information, what are the implications? While it's necessary for privacy, particularly with sensitive user data, and for continuous adaptation in a changing world,
There's a downside.
there could be. It also raises concerns about creating fake memories or the malicious erasure of critical information. For example, you wouldn't want an AI system used in a legal context to conveniently forget key evidence, would you?
Definitely not.
So the sources emphasize that any process of forgetting in AI systems must be transparent and auditable. We need to know what is being forgotten and why. The goal has to be therapeutic, aiming for better function and alignment, not manipulative.
Control and oversight are key.
Absolutely. Ultimately, we want AI to forget wisely, adapting and maintaining long-term health and trustworthiness. Much like biological organisms prune unnecessary or harmful memories to function better and maintain their well-being, it's about balance, letting go of what is harmful or irrelevant while retaining what is crucial and true. 4. Navigating the complexities, strategies for semantic integrity and control.
That concept of wise forgetting is truly compelling, and it highlights just how complex it is to manage an AI's internal state, its memory. So knowing what's really going on under the hood when AI hallucinates, what practical strategies are emerging? How do we build more robust and trustworthy AI systems that are less prone to these kinds of echoes of unknowing? It's clearly not a simple fix, but it sounds like we're developing some pretty sophisticated approaches.
We are. There's a lot of active research and development here.
One of the most promising avenues seems to be what's called human-AI collaboration, often referred to as hybrid intelligence systems.
Right, humans and AI working together more closely.
Yeah, and this concept moves beyond simply having humans oversee AI as a sort of last resort safety net. It's about explicitly combining human and machine intelligence right from the outset, carefully defining specific roles and interaction patterns based on the task and the level of automation required.
So designing the collaboration itself.
Exactly. For example, in a medical diagnosis scenario, the AI might process vast amounts of patient data, look for patterns, suggest potential diagnoses.
Things humans might miss in huge data sets.
Right. But a human doctor would provide the nuanced clinical judgment, the patient empathy, the contextual understanding of that specific patient's life, all the things the AI lacks.
A human touch, the wisdom.
Precisely. This allows humans to provide crucial oversight and intervention, precisely where AI is most prone to semantic drift or hallucination, catching errors before they escalate. It's about creating a synergistic relationship where each brings its unique strengths to the table, and the human intellect acts as a continuous regrounding mechanism for the AI.
Yeah, that makes a lot of sense. And this hybrid approach needs to be underpinned by robust technical and ethical strategies.
Okay, like what?
Well, on the technical side, robust prompt engineering goes far beyond just stringing a few words together or chaining prompts in a basic sequence. It involves things like iterative upgrade tests.
Testing and refining the prompts constantly.
Yes, and rigorously validating intermediate outputs. Instead of just giving the AI a single complex prompt and hoping for the best, you're designing prompts that include checkpoints. You ask the AI to show its work at various stages.
Like showing you're working in math class.
Exactly. You validate that each step of the AI's reasoning is sound and semantically aligned before allowing it to proceed to the next. It's like building a complex structure brick by brick and checking each layer for stability.
Much more controlled.
Much more. We're also seeing a significant move towards multimodal prompting.
Multimodal? Using different types of input.
Right. Combining different input types, not just text, but also code, visual data, audio, maybe even haptic feedback for complex tasks, particularly in areas like robotics.
Ah, like controlling a robot.
For instance, yeah. In controlling a robot to perform a delicate assembly task, a text command like pick up the screw might be combined with a visual cue from the robot's camera showing the screw's exact orientation, and maybe even code snippets detailing the precise movements needed.
So the prompt becomes much richer, more complex.
Exactly. This suggests that complex hybrid prompt objects are needed to capture the richness and nuance of real-world interaction. The very definition of a prompt expands from a simple text string to a structured, multi-component artifact that guides the AI more precisely and reduces ambiguity.
Which should reduce hallucinations.
That's the goal. By reducing ambiguity, you limit the opportunities for semantic drift and ensure greater fidelity to the intended task.
Okay, what else?
Another critical component is the development of robust memory interfaces and knowledge graphs.
Better memory for the AI.
Essentially, yes. AI systems need effective mechanisms to store, retrieve, and manage information over extended periods. This includes short-term memory, which is kind of like an LLM's context window used for immediate interactions, remembering the current conversation.
Okay.
But crucially, they also need long-term memory for persistent factual knowledge that can be recalled across different sessions or interactions.
Like a permanent knowledge bank.
Right. Technologies like vector databases enable efficient retrieval of relevant information that's essential for retrieval augmented generation, or AG systems, which pull facts from external knowledge bases to ground their answers.
Okay, RAG. I've heard of that.
And knowledge graphs, on the other hand, can store structured relationships between concepts. Think of it like a mind map for the AI, providing a more grounded and interconnected web of knowledge for it to draw upon, similar to how our human memory links related ideas.
So it understands connections better.
Hopefully. These long-term memory mechanisms are absolutely crucial for maintaining coherence and enabling learning over extended interactions. They help reground AI outputs and prevent hallucinations that stem from a lack of consistent, accessible, and correctly structured knowledge.
Makes sense. It needs a reliable memory.
Exactly. And finally, and perhaps most importantly, we need strong ethical AI frameworks and effective bias mitigation techniques.
The ethical dimension.
Crucial. Absolutely imperative. We need to prioritize algorithmic fairness and transparency. Our sources highlight that current systems, often due to biases baked into their training data, can lead to unfair representation in the content they generate.
Like stereotypes.
Exactly. An image generation AI might consistently depict certain professions with only one gender, or generate harmful stereotypes when prompted about specific cultural groups. We've seen examples of this.
Yeah.
Implementing robust bias mitigation techniques during training and deployment is key, and also providing users with insight and control over their recommendations and outputs. This can build significant trust.
Letting users understand and adjust what they see.
Yes. This directly addresses real user concerns about hidden influences on their media consumption or the content they create. It also means developing comprehensive ethical AI frameworks that promote AI awareness and foster human consciousness throughout the entire AI development lifecycle, from initial design right through to deployment and ongoing monitoring.
Building ethics in from the start.
It's about embedding human values and ethical considerations into the very fabric of AI design and operation, ensuring that as AI grows more capable, it also grows more responsible and trustworthy in its understanding of the world and its impact on it. V, the creative unintended. AI's unexpected outputs and cultural impact.
That's such a crucial point about building ethical foundations right into the AI itself. Now, while we've largely focused on the problematic side of hallucinations, the factual errors, the semantic drift, the biases.
Dangerous stuff.
Right. But AI also produces outputs that are unexpected, sometimes nonsensical, and at other times, well, surprisingly creative.
Yeah.
How do these more creative unintended outputs connect to our conversation about unknowing? And what are the broader implications for art and culture? It's not all just errors, is it?
Not always, no. Sometimes the unexpected is interesting.
Let's look at AI in image generation. That's a very visible example right now. Models like Stable Diffusion, DALL-E 3, they're incredibly powerful.
Astonishingly so, sometimes.
They can produce photorealistic images, often with astounding detail, especially when guided by detailed prompting and techniques like ControlNet, which allow for visual guidance alongside the text. You can specify everything from composition to artistic styles, creating images that, honestly, were once thought to be only within the realm of human artists.
It's democratized image creation in some ways.
It has.
Yeah.
But a major issue emerges here that directly connects to this unknowing cultural flattening.
Ah, yes. This is a big concern.
It is. When these models are prompted to generate images of specific indigenous cultures, for example, like indigenous Australians, they often produce content that is not only inaccurate, but deeply offensive.
Right. Generic stereotypes.
Exactly. Instead of representing the true diversity, nuance, and rich cultural heritage of Aboriginal and Torres Strait Islander peoples, the models tend to amalgamate features into generic, stereotypical, noble savage tropes. The images frequently include random, culturally meaningless body markings or adornments that have no basis in reality.
It's pulling from biased or superficial data.
Precisely. This isn't just a simple mistake. It reveals a dominant northern gaze embedded in the training data. The AI lacks genuine understanding of diverse cultural heritage and instead defaults to reductive, generalized, and often harmful representations. The AI simply doesn't know the culture.
And it fills the gap with cliches.
Right. It fills its knowledge gap with stereotypes rather than seeking true understanding. It's an echo of unknowing because it fills its knowledge gap with harmful biases rather than acknowledging its ignorance or seeking accurate information.
Which has real-world impact on representation.
Absolutely. And this leads to another fundamental failure point with significant cultural impact: the copyright and ownership impasse in AI-generated art.
Ah, the million-dollar question, who owns AI art?
Or perhaps the $0 question for the AI itself. There's currently a clear inability to secure traditional copyright protection for works deemed solely generated by AI, at least in many jurisdictions.
Which creates huge problems for commercial use.
Huge. It severely limits commercial exploitation, like licensing images for use in advertising or media, and leaves human creators vulnerable. If their work is deemed too close to an AI-generated piece, or if AI uses their style, the legal recourse is murky.
Especially with ongoing lawsuits about copyrighted training data.
Exactly. The whole training data issue, the vast amount of art and images AI models learn from without explicit permission in many cases, makes the waters incredibly muddy. And this ties into the unknowing because the AI's creative process often lacks transparency.
We don't know how it made what it made.
Right. We don't fully understand how it combines its training data to produce a novel image, or what specific elements it drew from. And this trust deficit, this lack of clarity on provenance and true originality, becomes a major barrier to valuation and market growth in the AI art space.
If we don't know the source or the process, how do we value it? Or assign ownership?
Precisely. The AI doesn't know how it created it in a human sense, and often we can't either, leading to this legal and economic vacuum. It's another layer of unknowing with very practical consequences.
Yeah, this cultural flattening and the copyright issues really expose the limits of AI's perception and the challenge of achieving true innovation, rather than just sophisticated synthesis or remixing.
It looks creative, but is it?
Well, consider hyperreal synthesis. AI can achieve extreme spatial resolutions. Think photorealistic images at 8K, even 16K pixels, far beyond what most displays can even show.
Super sharp.
Super sharp, yes. But this numerical improvement might not translate to a perceptibly more realistic or believable experience. One of our sources calls this the perceptual wall.
Meaning sharp isn't everything.
Exactly. If the angular resolution, how detail changes with viewing angle, or the fidelity of depth cues are insufficient, the image might still look flat or uncanny despite its incredible sharpness. It's like having a super high-resolution photo of a flat drawing. It's sharp, but it still lacks true depth.
Okay, I get that.
Even more tellingly, if subpixel details, which can be incredibly tiny, like micrometers tiny, don't correspond to coherent 3D structures across different views, they can appear as hyper-sharp noise.
Noise that looks sharp.
Yeah. The AI is replicating pixels with incredible precision, but it lacks a deeper understanding of the underlying 3D world that these pixels are supposed to represent. This leads to visual artifacts that betray its lack of true comprehension beyond mere pixel replication.
So it's a precise output,
But one that highlights a profound unknowing of the underlying reality it's attempting to render. It gets the details right, maybe, but misses the overall structure, the forest for the trees, so to speak.
right.
And even in more intentionally creative rendering, like trying to mix the concept of silica fur on obsidian,
Yeah.
a fantastical combination.
Yeah.
A source example. The AI, or rather the rendering software it's often working with, has to balance inherently organic qualities like the texture and flow of fur with inorganic optical characteristics like the transparency and reflection of silica, all against a dark volcanic obsidian backdrop.
That sounds complex to visualize.
Yeah, it is. And while an AI can implement complex concepts like this, following instructions from, say, a shader blueprint, it requires careful parameter control in sophisticated software like Blender to achieve the desired unifying resonance.
They're calling resonance.
That aesthetic harmony where disparate elements blend believably and create a compelling whole. The AI isn't spontaneously conceptualizing silica fur and its aesthetic implications or how it should look. It's following intricate instructions to achieve a specific visual effect.
So the creativity is more in the human instructions.
Often, yes. This shows AI can execute sophisticated artistic ideas, but it still frequently requires explicit guidance and a human hand, or at least very detailed human intent, to achieve that unifying resonance that transcends simple combinatorial creativity. The creativity in these cases often resides more in the prompt and the human curation than in the AI's inherent understanding of aesthetic harmony or novel conceptualization. It executes, but doesn't necessarily originate in the same way. Broader echoes. Human knowledge systems and AI's mirror.
That distinction between execution and true conceptualization is really key, isn't it? And this whole discussion around AI's unknowing, its hallucinations, its impact on knowledge, it feels like it has incredibly deep human parallels. It's almost as if AI is holding up a mirror to aspects of our own history and our own understanding, highlighting universal challenges in how knowledge is formed, preserved, and sometimes tragically lost.
It definitely resonates with human history.
Where else do we see these echoes in our own past and present human knowledge systems? Let's consider epistemicide, a really powerful and frankly unsettling concept from our sources.
The destruction of knowledge systems.
Yes, and this isn't just about losing information, incidentally. It's the deliberate destruction of indigenous or pre-existing knowledge systems, often as a tool of conquest and control.
A weaponization of ignorance.
Exactly. The most stark example often cited is the Spanish obliteration of the Inca Cupu system. Their sophisticated, not base record-keeping. It contained vast amounts of historical, economic, cultural information.
All encoded in knots. Amazing.
Amazing, and tragically lost, largely. The Spanish destroyed the Pipus and brutally persecuted its keepers, the Quipucameocs. This act caused not only immediate violence, but enduring suffering to profound cultural loss, a brutal severance from ancestral ways of knowing that continues to impact communities today.
A devastating loss.
And there are other tragic historical examples. The Qin dynasty's burning of books in ancient China, aimed at consolidating power by erasing dissenting thought. Or the destruction of the legendary Nalanda University's library in India, which supposedly burned for months, incinerating centuries of accumulated Buddhist and scientific knowledge.
Horrifying to think about.
It is. And the connection to AI's unknowing is, well, chillingly resonant. Just as human actions can lead to the systemic loss of knowledge and the silencing of voices, AI's epistemic drift and cultural flattening, which we discussed,
can lead to similar outcomes. Misrepresentation, stereotyping.
The effective erasure of nuanced cultural understanding through biased or incomplete data representation. It's a form of algorithmic epistemicide, even if unintended. The very mechanisms of AI's learning and generation can inadvertently degrade or eliminate vital knowledge and diverse perspectives simply because they don't fit the dominant patterns in the data.
The AI, in its unknowing, perpetuates a form of knowledge suppression.
Exactly. Then there's the beautiful complexity of quantum storytelling and entangled meaning, particularly as found in indigenous dreamtime narratives of Aboriginal Australia.
Quantum storytelling, how does that work?
Well, these aren't just simple stories with a single fixed meaning. They're described as quantum-like systems where narratives have a profound mnemonic function. They help people memorize and transmit vast amounts of multi-layered knowledge.
Knowledge tied to place, to law.
Exactly. Deeply connected to country, the land, law, and social structure. Imagine the concept of wave function collapse from quantum mechanics aligning with the actualization of specific interpretations of a story.
So the meaning depends on the context.
Precisely. Based on the audience, the place, the time. A Dreamtime story isn't just one linear narrative. It holds multiple potential meanings, and its truth is revealed and shaped by who is telling it, who is listening, and what is relevant in that specific moment or place. It's fluid and responsive.
Wow.
And entanglement refers to the intrinsically interconnected mnemonic web of song lines, where myth, ritual, physical place, and kinship are inseparable parts of a holistic knowledge system. Everything is linked.
That's incredibly complex.
It is. And it highlights how complex, interconnected knowledge resists simplification or reduction to simple categories. AI's probabilistic nature, which often seeks the most likely or generalized answer, fundamentally fails to capture such entangled meaning.
It tries to flatten it.
Right. It leads to semiotic collapse when faced with such rich, nonlinear forms of knowing. It tries to simplify and flatten what is inherently multidimensional and deeply contextual.
It can't handle that level of interconnectedness.
Not easily, no. And finally, just looking at language evolution itself in our own human history, Take English words, for example. They've absorbed countless influences from Latin, Greek, Old Norse, French.
Creating layers of meaning.
Exactly. This isn't just about adding new words. It's about creating nuanced synonyms and subtle semantic distinctions. Think about how many words we have for walk, stroll, saunter, march, amble, each with a slightly different flavor, a different connotation.
Right, subtle shades of meaning.
This constant evolution, this borrowing, this layering shows the dynamic, living nature of meaning in human language, where new nuances are constantly created and integrated. It's usually productive.
Contrast that with AI's semantic drift.
Exactly. With AI, the loss of nuance or original meaning is often seen as a failure rather than a productive evolution. The AI doesn't organically evolve meaning in a way that enriches it. It often misinterprets or degrades it, losing the very layers of subtlety that human language has built up over centuries. It drifts away from meaning rather than towards richer meaning. 7. The path forward. Cultivating resilient and responsible AI.
So, if AI's unknowing reveals its limitations and even mirrors some of our own historical challenges with knowledge, how do we move forward? How do we build systems that are not only more reliable, but also deeply aligned with human values?
Yeah.
Systems capable of navigating the true complexity of information rather than just flattening it or drifting away from it.
Yeah, what's the path forward?
Well, first, governance itself must be an adaptive process capable of navigating complexity and uncertainty.
Meaning the rules need to evolve with the AI.
Precisely. The rules and oversight for AI cannot be static documents written once and forgotten. We need novel approaches to auditing to grapple with the emergent behaviors and distributed dynamics we see in these complex modular intelligence ecosystems.
Because traditional audits won't work.
They're often insufficient. Traditional audits designed for simpler, more predictable software just can't keep up when dealing with systems that can shift and change their own internal logic in unforeseen ways. We need a more dynamic, real-time, and proactive approach to ensure semantic integrity and prevent harmful drift before it causes significant problems.
Building in checks and balances that can adapt.
Exactly. That can evolve as the AI itself evolves. Second, the future of AI development must fundamentally be human-centric.
Focused on people, not just the tech.
Right. The goal is not just to fix errors or make the AI faster, but to foster a richer, more profound human AI understanding. This shifts our objective from merely de-blackboxing, trying to understand every single line of code or every connection within the AI's vast neural network, which might be impossible anyway.
Right, the complexity is huge.
It is. Instead, we shift towards exploring larger patterns, building human intuition about the AI's behavior, and developing a nuanced feel for the network's overall tendencies, strengths, and weaknesses.
Understanding its personality, almost.
In a way, yes. Success in this new paradigm won't just be measured by accuracy or speed of output, but by more qualitative aspects. Things like user engagement, the depth of insight achieved by human users working with the AI, and the AI's ability to foster new hypotheses and creative solutions in human collaborators.
So how well does it help us think?
Exactly. This aligns with what's sometimes called information aesthetics, valuing the human experience and understanding, not just raw computational output. It's about how the AI helps us think better, not just do faster.
I like that framing.
And finally, continuous learning and self-correction are paramount. We need to design AI agents and hybrid systems that can learn from both visual and non-visual feedback during task execution. Learning on the job, essentially.
Adjusting in real time.
Yes, dynamically adjusting their strategy in real time. This means preempting failure by recognizing early warning signs, optimizing performance on the fly, and constantly refining their approach based on interaction and new data. This requires robust recursive interaction, where different AI modules or human AI interfaces actively reshape each other's outputs and internal states, creating a constant dynamic feedback loop for improvement and refinement.
So the system learns from itself and its interactions.
Exactly. It's about designing systems that can learn not just from static data sets before deployment, but from their own mistakes and interactions in the real world. Systems built to evolve towards greater semantic integrity and true understanding in a constantly changing environment. Outro.
Wow, what a journey that was. From the micro level of how AI processes symbols and those deep historical parallels of knowledge destruction.
Right up to the macro level.
Yeah, to the macro level of cultural impact and the really complex ethical dilemmas of memory, control, and bias. It's clear that AI's hallucinations are far more than just simple errors, aren't they?
Definitely not simple.
They are complex phenomena that reveal the very architecture of its understanding, and indeed, its profound unknowing. Those echoes are telling us something important.
And we've seen how these glitches, these echoes of unknowing, can actually serve as crucial diagnostic windows. They can guide us toward building more robust, more ethical, and more transparent AI systems.
If we choose to listen to them.
Right. The imperative isn't just to fix the errors on the surface, but to truly comprehend their origins, their implications, and what they tell us about the nature of machine intelligence itself and its limitations.
Ultimately, it feels like the quest for semantic integrity in AI is, well, it's a mirror, isn't it? Reflecting our own understanding of knowledge, of meaning, and the biases inherent in all information, human or machine.
It really is. It's a continuous process of learning, adapting, and yes, maybe even therapeutically forgetting what doesn't serve us or what's incorrect in the pursuit of better understanding and better systems
For both us and the AI.
for both. And this raises a really important, maybe even unsettling question for all of us to ponder. As our increasing reliance on AI with its inherent echoes of unknowing continues to grow, how will our own definitions of truth, knowledge, and even reality itself be reshaped by interacting with these systems?
That's a heavy thought to end on. Something to definitely ponder as you navigate your own information landscape, dealing with AI outputs every day. Thank you so much for joining us on this deep dive.